Hey guys, module 2, and today we're looking at molar mass. So we've looked at making molar, producing hydrogen in the lab using the syringes. And so here comes some of the theory that goes with what we were looking at. So our molar mass, all substances take up space, and obviously they have mass. So how do we measure the mass of that and something that is so small in a reasonably accurate way? So our scientists have, through careful calculations, calculated Avogadro's number. From that, they have worked out the number of particles in a mole. Remember, mole is a counting unit that helps us compare one substance to another. So if we already know the number of moles that we might need of a substance, we can use this concept to calculate how many grams we're going to need. And they're the calculations we are doing for this prac. So the number of different elements and compounds have different masses. So if you look on the periodic table, you will see that all our elements do have a different mass. Hydrogen 1.008. Then we have chlorine 35.45 and so forth. So obviously the mass of each particle there is different for every element. So if I had 1 mole of magnesium, it would be 24, I think, 0.305, and that is its molar mass. That's the mass of 1 mole, and it's given the symbol, usually mm actually, and the unit grams per mole. So we've already talked about Avogadro's number, and that is the number of particles, ions, molecules, or whatever in a substance, 6.02 times 10 to the 23, and that's all based off carbon 12. So what we are looking at, if we want to find the formula mass of an element, we add together all of the atoms that are there. So for example, if it was chlorine 2, then you add together. So the number of subscripts, the subscript number will help determine how many atoms are present, and that will allow you to work out the molar mass. So when we're working out the molar mass of chlorine, it is not just one single chlorine atom, it's Cl2, so you will have to double that. So the molar mass does have other names. Molecular weight is one. Obviously that works if it's a molecule. Formula weight is another. Atomic weight is another. It's probably just as easy to use the word molar mass, and that's what I'm certainly going to use in class. Now the formula for molar mass is grams divided by moles. So if I had 24.35 grams of magnesium, and I know that's how much is in and I know I've got 1 mole, so 24.35 divided by 1 mole, the molar mass would be the same. So it's all just a manipulation of what we have been looking at there. So we have looked at those calculations that I have given you for how to calculate those values for an element with the hydrogen prac. Looking at the molar mass of a compound though, compounds are a little bit different. They're made up of more than one element, and those are there in fixed ratios. So again, this is where we talk more probably about the formula mass, and it's usually the molecular mass, but we are looking at all the atoms that are in that formula. And that's what you're going to do in an activity for me today. So to find the relative formula mass of an element, you have to add together all the atomic masses together. So if I've got calcium chloride, I would find the atomic mass of calcium and the atomic mass of the 2 chloride atoms that might be there. Add them all together, and that will give us our formula mass for that compound. There are questions in the review set following that I want you to go through, and you will have a go at practicing calculating the formula masses or the molecular masses or molar masses for each of those substances. We'll talk about it a bit further in a bit more detail. See ya.